This is a presentation about metaverse messaging and how it works. Something that Ari Lynn and me, Granddad Got Mojo, have been working on for the Teen Music Oasis for a number of applications. First, I'm going to talk about scripting inside of Sansar, simple scripting. And here we have a simple scene with a doorway, a trigger volume or collision volume, and on the other side of it there's a light. And the whole thought process is that as you walk through the door, you will hit the collision volume, which will send a signal to turn on the light. So basically it's to understand what goes on in simple messaging inside of Sansar. Each element in the scene, the door, the trigger volume, and the light are an object. What's an object? Well, an object is it's basically just a set of code associated with the object. And they're called instances, these sets of code, as they're implemented inside of the system, or inside of the scene when it's compiled. And the objects created on the server, we have a client-server kind of architecture with Sansar. And there's numbers of things about the object. It's got a state, it has variables or properties that contain data. And also it has methods or functions that can be called to query the state of that object. Like, have you touched the trigger volume? Is the light turned on or turned off? And so on. So what's a script? Well, Sansar decided not to let us programmers change their server code directly, although a lot of times we wish we could. They chose to let scripters extend the object's code. So basically each object in there is really a set of code. And you can go ahead and attach a script which really says, I'm going to extend the code of that object that Sansar has already developed. And so what they do is they say, for example, in terms of a light, they'll expose certain properties or methods inside of the light. Because if you look at the light, light's not physically a light. A light is a chunk of code. It's a class inside of Sansar, inside of the server. So they expose it, and that allows us to change the behavior of the object by changing those properties and calling them methods. Some, but not all properties are exposed. They make the decision. For example, we can change the position rotation of an object, but we can't change the scale of it. So what are the rules for scripters and scripts in an object? Well, scripts are placed in an object. They control aspects of how the object behaves in the simulation running on the client. So basically, it's in the server, it's running, and it sends information down to the client. They can only control the objects they are in. So, for example, a script added to the trigger volume cannot directly turn on or off the light because it can only control or only can interact with the code that's inside of the trigger volume. So that's the major point of simple scripting. How do you control turning on and off the light then? By how you interact with the trigger volume? Well, that's what's called messaging. Basically, the scripts can talk to each other, allowing one script to ask another script to perform a certain change in behavior. For example, trigger volume can have a script, and it sends a message that a script has been is listening for in the light, and the script in the light then changes the value. The server then sends that information down to the client. So basically what's happening there is the trigger volume talks to the sends a message at the server, and the script which is running for the light on the server is listening to it, and then when it decides what to do, it then sends the information down to the client to change what the light does, turns on or off. Actually, basically, it because that's part of the regular client server relationship. So basically, here's what we're trying to do here. We have a trigger, we have an event, and we have an action. Input, event, output. So keep that in mind all the time. They're separated. You know, and you can have a kind of a even more generic. I mean, it doesn't have to go input directly to output. It can go to input with a message, and there might be it might be a logic script listening for it that makes some decisions and controls what happens to that, and then it sends it to the output. And sometimes the logic script can be separate, or it can be, you know, embedded. The logic can be embedded in the input or the output side of things as well. So just kind of that's a general approach. And you've seen this before, but this is an example of how this would work inside of a given world, a Sansar world. You'd have a light on, it would send an event. The one on the left-hand side is a collision, the one on the right-hand side is a light. So basically, you say when the agent collides with it, send a light on message or event. And you have scripted over here on the light on, light off script to be listening for the keyword light on. And what will it do? It will turn it on. So there's code in there on this simple script that does that. It changes the state of that light to being on. Light off sends a message, light off message, and this is listening for a message named light off. So if you call this anything besides that doesn't match up here, of course it won't work. And we use it for a lot of things. This is just a short list of all the different kinds of inputs and triggers and all the kinds of things that you can control with the output. And these are mostly simple scripts, but I mean, you know, when we talk about simple scripts, so real quick here, I mean, simple script is just one person, which was Kelly's, way he packaged up the API or the functions that they're exposing, and called them simple scripts. You know, and he said basically, well, here's the major things you can do, and here's the major things you can kind of signals you can send, and here's the major kind of things, actions you can take. There's many more than this, and so and you're not tied to nothing special about simple scripts. It's just a script. So I myself, for example, you know, or we will write our own scripts. We write a lot of our own scripts because the simple scripts doesn't do exactly what we want. So let's talk about metaverse messaging. Well, obviously, or it should be obviously, that if you click on if you have a collision, the trigger volume, the only thing that's listening for it is in that world. Because there's a server instance running, and there's a server instance running for let's say there are 4 or 5 of you are in it. You're in the same server. There's an instance running on the server of that world, and so if you click turn on a light, only objects inside of that instance of the world will be listening for it. Nothing else will be. So again, as we look at our example here of the input sending a message with an event, subscribing to the message, and the output all inside one world, it looks something like that. And that's what we saw earlier. That's your normal approach. Well, what would we do that's different? Well, the blue here, the blue boxes are things written in Sansar. And you'll see a difference here in a few minutes about things that are written outside of Sansar. There's an MMS meaning Metaverse Messaging System, and that's what Ori and I have written. I've written the how to get into them, and she's written the backbone. So the MMS sender script builds an HTTP message. What's HTTP? I mean, that's basically the language of the web. It sends an HTTP message based on the simple script. So basically what happens is this script is running, and it's listening for that message. It's listening for the light on, for example. And then it builds an HTTP message and sends it via HTTP to a server. And where does it send it to? It's linked to something known as the API gateway. So, and that is read and it's written in Amazon Web Services, and Ori did this. And there's an API gateway. It's a connection point. And what happens is it basically does what's called a post. On a post, you'll see some words of how they communicate. Basically what a post does is says, hey, I'm going to send a request to you to go do something. I want you to do something on your side. So it basically sends the information associated with the light on message. And the API gateway gets it back, and if it receives it and everything was okay about it, it sends back a response to say, okay, I got it. So it basically sends back a I got it or didn't get it message. And then we execute, you'll hear us word lambda, and all that is that's a program in Amazon Web Services to do something with that message it received. So it's basically the controlling program inside of Amazon Web Services. And what it's going to do, in this case, is, as you said, light on, it's going to go ahead and put into a database. That's a SQL database that's running inside of Amazon Web Services, the light on message, and what other information you sent with this. Now, a real quick thing here. Simple messages basically only send messages. We send, in this kind of case, messages in what we call a payload. And you'll hear us use the word JSON. And JSON is just a standard way of formatting messages up or formatting data to be able to pass it. So you could pass anything here, not just the message, but message on a whole bunch of data that you want to go send. So that allows you to do a lot more than you can do with just plain old scripting. You can really send complex messages as well. The data is stored on the database. Okay, and now the second side here we're going to do, now that you know the data is on the database, and so the send has already been done. Over here again, we had we want to receive it. So what we have here is we also have, just like we had a sender script, we have a receiver script. We have the MMS, the Metaverse Messaging System receiver script written in Sansar script. These two, again, the sender script and the receiver script are written in C# and running on the Sansar server. And what it does is says, it's a little polling program that you decide how often you want it to go look. So it's running on the server and it's running in the world that you've got. And it's saying, hey, every so often, let's say every second, go make a request to the gateway and say, have you seen any light on messages? Basically, that's called the HTTP GET. It says, go get any light on messages. And it goes again through the Lambda function, which is basically the controller, goes, looks in the database, does a query, is there any light on messages? And it retrieves that information. And once it's got that information, it will send it back. And the receiver script then builds a simple script message. So it takes the data that it got out of the database and says, oh, I need to communicate with the Sansar server, so I need to be using a simple script message, or it doesn't have to be a simple script message. It can be something called a reflective message, but let's just say a simple script message. And then once it's got that built, it sends that event and it turns on the light. So basically what it does is it says, hey, turn on a light, sends it to the gateway. A second later, this other script is listening to it and says, hey, do you have and a second is just an arbitrary number. You know, you can set it down to much faster than that, although there is a throttle on how many commands, how many times a second that you can do this. And it goes to the API gateway again, gets the data, and creates a simple script message and sends it on to the back to the server. And there's a subscriber, simple script subscriber message in the light that's listening for and turns on the light. Well, that seems like a whole lot to do when you could just send this event. But what makes this more powerful is be different worlds. So basically you have Sansar World 1, sending to Sansar World 2. So basically you're saying, hey, send a light, boom, boom, goes down here. And in the second world, there's a receiver script that's listening for that message, and it turns a light on in the second world instead of the first world. And you're not, hey, this is, it's a web, and whatever you can do to interface with the web. So you could write an LSL script in Second Life and turn the light on in a Second Life if you wanted to. And by light, you can do anything. Anything you could do, any action that they expose their API, either in Second Life or Sansar, you can do. All right, so integrated applications, you can do just what we showed there. Basically, Sansar messages going into AWS, Amazon Web Services, and communicating with the web application. It's another way you can do it. So this web application could do things like, be a jukebox. It could play different songs. So it would select different songs and then play them back in Sansar, or change a screen, or change information. Or in this kind of case, you could send it to a web application that changed media playing, or was a game. There's all kinds of things that you can do with this generic architecture now, with AWS in the middle of virtual worlds and web applications. Here's a few of the ideas that I just came up with off my top of the head, and we'll go look at them. Obviously, the one I just showed, and of integrating Sansar worlds via simple scripts, and the most obvious use of this is when other instances get spawned, and things like with our big music show we had. If there's new ones, it could go send state information of saying here is what's going on in the first world. So make sure the laser show is playing at the same place that it is in the first world and the second world, that type of thing. You could have persistent data applications, things like, because you could be not just storing it in the generic kind of queue manager database I showed you a minute ago. You could be storing it in a specific application. So things like scoreboards, voting. We could do a group integration. So it doesn't have groups right now, but we could provide a group service for Sansar. You could track visitors. You could message visitors as they came into places. You could build games. A number of different things we could do if we're storing the data, and it stays persisted between different times you've come into the game, or come into that world. Again, that we could do the second Sansar to Second Life, or Sansar really to any other virtual world, and bridge their scripts. You could have games between worlds. I would like to do a family feud between different worlds. You could start and stop videos in different worlds at the same time, that type of thing. I believe we could integrate chat and messaging between Sansar and Second Life, and also to Twitch and YouTube, which I think is a good thing going down the road. And there's a whole bunch of web applications I have here that I want to go play with that are music oriented. Obviously, a jukebox request to a radio station that's playing. I want to do a MIDI DMX real world life laser shows. So basically, use existing software and hardware and integrate it to change lasers inside of Sansar, and then hopefully sell that to the people that are building that equipment. Control a web-based looper sample, and basically what that's saying is I have a looper. I had beat blocks. I messed around with synthesizers, not much, and I have another one called a riffer, which is a type of generates melodies for you. All those I want to move out of their existing applications that are very limited inside of Sansar. and build it external to Sansar, and then just have Sansar send information about how to change things in it, and then the external application be playing the samples and stuff. Right now I'm limited to just the number of samples I've uploaded into Sansar. Here I'll only be limited by, you know, how many I want to go put in a database and share with people. And also it would allow other people to use their samples. Control a Jamulus, and that's just another project I have going on. And that's real-time music collaboration, two people playing guitar together, real-time, and via Sansar. Web games, again, I'd like to do a calendar integration. You've seen all those. And a number of other things. And so that's basically where I've got. And so that's all I've got there. Real quick, I'm going to kind of show the steps here, and we will do the I'm going to get in here. I'm going to let me double check this. Yeah. I'm going to get in here real quick and just show you how it really looks. So if I look at those, I'm going to go look at maybe a good example here. Because you heard a bunch of things, but to see them, it makes more sense. At least it does to me. So if I look in here, and here's an example of the. So I have this. Remember, I talked about senders and listeners. This is a simple script listener. I say, here's what you need to connect to, and that's the AWS, which is Amazon Web Services running. And if you look at it, it looks like things you see on the top of your browser. It's using the same protocol to communicate with that your browser uses and all HTTP applications use. And it says, if you hear light on external, I want you to send out the word. I want you to send out a message called light on 3, and only wait 0.12 seconds. So do it very quickly and send it out. And if I looked at, and then if I would go look at a second world here, so that's sent the word. It sent light on 3. So it's done this. If you remember, it sent light on 3 into the database, into the AWS event database. And if I go farther, so then I've got another world here that is it's on the other side. It's listening. Down here, I have down at the bottom here, I have the Metaverse messaging system listener, and it's listening for light on 3, and it says it says here's the throttle again. Every second, it's saying, hey, is there any light on 3 messages out in this database? So that's what it's doing. It's polling, and of course you could set that lower that time, and when it sees that, it sends a light on 3 command in this world. This is a second world, and there's a light over here. It's listening for light on 3, and so that's how that works. So I mean, I could show you the little bit of code. I mean, the code that's sitting inside of the Lambda and stuff, but basically all that's doing is just getting the data. It's getting the data off of the message and the payload, and putting it on the database, and then taking it off the database and the request side. So that's it.